Hey y'all, what's going on? It's your favorite soft-spoken scientist. Today we're going to be picking up where we left off, okay? So we have 0.0300 moles of NaOH. It's going to react with H₂SO₄. How many moles of H₂SO₄ reacted? Well, first of all, H₂SO₄ is an acid. So I would just share that real quick. Now, the balance equation is H₂SO₄ plus 2 NaOH is going to form Na2SO4 plus 2 H2O. Wow, that's a lot, right? So I'll do it a video showing y'all how to balance equations, so don't worry, but sometimes I'll give it to you. So what I did was I said to myself, let me just make sure everything's equal on the reactant side, which is the left side right here, you guys see reactants, and then the product side, which is the right side. Okay, so there is one SO4 underlined on this side, and then there's one here. Perfect. There's 2 sodiums with the star on the left, right here. There's 2 sodiums right here. Okay? And then this 2 gets multiplied to that sodium, that's 2. There's 4 hydrogens because 2 times 2 is 4. There's 2 hydrogens here. And then Peek, I'm show you the other one. There's other one. So 2 plus 2 is 4. So there's 4 hydrogens. So everything is balanced. Now, the coefficient in front of the coefficient 2 in front of NaOH means 2 moles of NaOH react with 1 mole of H₂SO₄. Because remember, there is an invisible one right there. Okay? That ratio creates the 1/2. So they gave me 0.0300 moles of NaOH. Now, I'm going to say, okay, for every 2 moles of NaOH, I got, in purple, 1 mole of H₂SO₄. Alright? Because they said, how many moles of H₂SO₄? And I'm giving moles of NaOH. I don't need to mess it up and go to grams, none of that. So moles of NaOH cancels out. So 0, and then when you multiply it, you'll get 0.0150 moles of H₂SO₄. I know that 2 is like 1 sig fig, but it really wouldn't be fundamental in the sig figs here because it's just a whole number. So we would just do 3 sig figs, right? So 0.0150 moles of H₂SO₄. Plus, if you only had 1 sig fig, that wouldn't be really specific. All right, so that is how you do this problem. Now, let's move on to the next question. So before I do, I want to give you guys this formula, and I'll explain what they mean. So you got Ka equals H plus times A minus all over H of A. Okay? This is a formula you use when you're trying to use like acids and conjugate bases, stuff like that. So let me explain what this means. Hydrogen is positively charged, which would represent acidic. Okay, acid. And the more, so this is the deal. This is the acid This is the acid dissociation constant for a weak acid. This equation is called Ka. Again, the acid dissociation constant. It tells us how much a weak acid dissociates in water. So let's break it down. Ka is a constant number. All right? It's a constant number. You're measuring acid strength. So here is a rule you need to know for Gen Chem 1 and Gen Chem 2. Please pay attention. This is always at an exam. Larger Ka is a stronger acid. The smaller the Ka, just weaker acid. Drill that into memory. I can't express that enough. Okay? The brackets, they just mean concentration. Their units are molarity. They're not that, you got it. So H plus is the concentration of hydrogen ions. This is what determines pH. Okay? So H plus is hydrogen and determines pH. Okay. A minus, you guys. Let's take a look here. This is the concentration of the conjugate base. The acid after it loses hydrogen. All right? Now you got HA. This is the concentration of, and it'll all make sense, I promise, undissociated weak acid. So it's still holding onto the protein. So holding the protein. Proton. We are not doing biology yet. Okay. A weak acid dissociates like this. This is how they dissociate. You got HA, which represents what? There you go. It's representing of the undissociated weak acid. So you got HA. It can be broken into H plus and A minus, and then these can make HA, which is what the double arrow represents. Ka is products over reactants, excluding pure liquids. That's why water is not included in this equation. Only aqueous species appear in the Ka expression. Solids and liquids are never included. All right, you guys got the idea. Let's take a look at this problem. A weak acid has H plus of 1.0 times 10 to the negative fourth, A minus of 0.020, HA of 0.200. Calculate Ka. Let's do it. We know the formula. Ka equals what, you guys? H plus times A all over HA. So it's like, the way I was seeing it is like, real quick, it's like H and an A are gonna make, corny, but y'all, you got it, okay? So let's plug it in. So we got Ka equals 1.0 times 10 to the negative fourth times an A of 0.200. Oh, no, 0.020. Gosh, it's like I'm blind. 0.020. Careful there. And then HA is 0.200, right? So you're going to get 1.0 times 10 to the negative fifth when you plug that into your calculator. All right. Let's talk about Henderson Hasselbalch. You got pH equals the pKa plus log of A minus all over H of A. So pH just measures like how, if something's like acidic or basic, right? So if you have a really low, let me just start with this. If you have a really low pH, are you acidic or basic? You're acidic. If your pH is at 7, you are neutral. You know how some water brands are like, our pH is 7. You're just, don't fall for that. You're just like, oh, boo. So you're supposed to do that. So if your pH is 9, 8, 9, 10, 11, 12, 12 is like the max, you are really basic. All right? So let's talk about this real quick. This equation, though, is called the Henderson-Hasselbalch equation. We use it only for buffers, and it lets us calculate pH directly without using an ice table. That's some next level stuff. We'll get to that later. Okay. Again, pH is how acidic or basic the solution is. pKa comes from Ka, and here's the formula you guys need to know. pKa equals the negative log of Ka. Tells us the strength of a weak acid. All right. A minus is your conjugate base. I just wrote Cb. This is the acid after it donates hydrogen. Ha is the concentration of a weak acid, and it's still holding on to that proton. The Henderson-Hasselbalch equation only works when both A minus and HA are present. That's what makes a buffer, all right? So let's try this problem together. A buffer has a pKa of 4.75, an A minus of 0.100, and HA of 0.100, right? So what's the pH is what they want to know. So I'm going to plug this in. Let's say pH equals the pKa of 4.75 plus the log. What's my A minus? 0.100. What's my HA? 0.100. What's 0.100 times 0.100? 1. So I got pH equals 4.75 plus log of 1. This is something you guys need to understand. Log of 1, something to memorize, is 0. Know that for physics, know that for chemistry, know that for calculus, algebra, everything. Okay, log of 1 is 0. So it's 4.75 plus 0, basically. 4.75. This is the answer. All right, hopefully that wasn't too bad. All right, let's try this one. Number 6. So, you got a 0.200 as an A minus and an HA of 0.0500 with a pK of 4.75. Find pH. So, which formula do you guys think that we're going to have to use on this one? Exactly, we're going to use this one, Henderson Hasselbalch. So let's write that in. We got, say it with me, pH, because you have to memorize these formulas, equals pKa plus log of what? Yeah, A minus over HA. Haha, remember that rule? Okay. It could still work on this. Okay. So I'm going to put my parenthesis and then my brackets down here, my brackets up here. Okay. So because this is a buffer, we're going to use Henderson Hasselbalch. So let's write out what we know, right? So pH equals 4.75. They told me that. Bam. Plus log of A minus 0.200 all over H of A, which is 0.0500. All right. I always plug in first before simplifying so I don't mess up the ratio. What's 0.200 divided by 0.0500? If you do that, you're going to get 4. So you got log of 4 plus 4.75. Because this whole thing is log of 4. All right? The conjugate base concentration is larger than the acid, so I already expect the pH to be greater than the pKa. This is a great intuition check, all right? So, log of 4, if you plug that in your calculator, you're going to get 0.602. Plus the 4.75, that's going to get you a pH that is 5.35. So, here's something you guys need to know. This is really, really important. Because A minus, as you saw, is greater than H of A, right? Would you guys agree 0.200 is greater than 0.0500? I would. Yeah. So because A minus is greater than H of A, the solution is more basic. Drill this into memory. This is, I can't express this enough. Like, I can put a big star. That's how you know I'm serious. So the pH must be higher than the pKa. And 5.35 makes sense. Here is a summary of what everyone needs to know. And I'm going to write this once and one time only. So, if A minus is greater than H of A, pH is greater than pKa. If A minus is less than HA, and you can figure this out in the question by reading the question stem, pH is less than pKa. If A minus equals H of A, let me just add the brackets to look fancy for you guys, okay. So, if A minus equals HA, your pH equals the pKa. This is literal gold. I wish I saw this when I was a little younger. Okay,